Let's say we want to roll a 6-sided die. And so let's write the sample space for that. So we have 6 possible outcomes. We can get any number between 1 and 6. Now let's say that event A includes the outcomes all natural numbers less than or equal to 4. And event B has the outcomes 3, 4, and 5. Given this information, what is the probability of event A and event B occurring? What do you think the answer is to this question? In order to find out, the first thing we need to do is write the sample space of events A and B. So this is the intersection of A and B. So the numbers that correspond to event A and B are 3 and 4. Now the probability is equal to the number of favorable outcomes divided by the total number of possible outcomes. So we have two numbers where A and B will both be occurring out of 6 potential outcomes. So the probability is going to be 2 over 6, which we can reduce that. 2 is 2 times 1, 6 is 3 times 2, and so this becomes a probability of 1 over 3, which has a decimal that's 0.33, or 33%. That's the rounded answer. Now, what about the probability of event A or event B occurring? What's the answer to that question? Let's write the sample space of A or B. So this is going to be the union of these two events. So basically, it's going to be all these numbers combined. Event A occurs anytime we get a 1, 2, 3, or 4. B occurs if we get a 3, 4, or 5. So this will include everything except 6. So there's 5 favorable outcomes that lead us to get an event A or B out of a total of 6 possible outcomes. So the probability is 5 over 6, which as a decimal, that's approximately 0.83. The 3 is repeated. So that's about 83.3% chance of getting A or B. Now, what about the complement of A? What is the probability of getting a complementary event? Well, first, we need to write the sample space of the complement of A. So this includes everything that is not A. So out of our sample space of 1 to 6, A is 1 to 4. So the other numbers that are not in A but still in our total sample space are the numbers 5 and 6. So the probability of getting the complement of A is going to be 2. We have 2 favorable outcomes out of a total of 6, which is going to be 1 over 3. Now, what about the probability of getting event A, or of event A occurring? What would you say? Now, there's 4 favorable outcomes that lead to event A out of 6. So 4 over 6 reduces to 2 over 3. Now, there's something that you want to take notice of. Notice that the probability of event A occurring plus the probability of the complement of event A occurring adds up to 1. P of A is 2 over 3, and P of the complement of A is 1 over 3. That is 3 over 3, which is 1. So this tells us that if we wish to calculate the probability of a complementary event, it's 1 minus the probability of that event occurring. Make sure you write this equation down because it's going to be useful in the future. Let's work on this problem. If the probability of selecting a red marble in a bag full of marbles is 35%, what is the probability of selecting a marble that is not red? So the probability of getting a red marble, we're told, is 35%, which is 0.35. So what is the probability of getting a marble that is not red, or the complementary of R? Based on the formula that we wrote before, it's going to be 1 minus the probability of getting a red marble. So it's 1 minus 0.35, which is 0.65. So there's a 65% chance of getting a marble that is not red.